Hello, geometry students. Today we are going to be going over and reviewing how to write some proofs and start with conclusions and reasons and justifying things. So these are just some short proofs and practices for you to be able to practice justifying. All right, so your directions say in each problem below, given, the hypothesis will lead you to a specific conclusion based on geometric definitions. Using the diagram and given information, determine what direct conclusion can be made in each case. Be sure you can support your conclusion with the definition. So if you have not completed this worksheet, you need to stop the video right now and complete the worksheet. So if you want to do it one at a time, like come up what you think the first one is, and then if you're struggling a little bit, go ahead and play the video for a little bit. But I'm telling you right now, the more practice you get in writing something down and then going through and correcting it, the better off you are going to be in the long run. So please, please, please make sure that you are practicing. All right, in number one, if we are given AC is congruent to CB, kind of depending on the way the proof is going, there's two different ways you could do this. So one way we could say, if we know that AC is congruent to CB, a conclusion could be that C is the midpoint. Okay, that is a conclusion that we can come up with. C is the midpoint. Why can we say that? Well, that is the very definition of the midpoint, is if the two things on both sides are going to be congruent. That is the definition of a midpoint. Another thing, just depending on what they're asking for, which I'm not going to be extremely picky about on your proofs, but if you were in technology and you were having to write code for something, every little thing makes a big deal. So if you're dealing with code, this would be a huge deal. I'm going to be mainly working on the overall big picture. So another thing that you could maybe deduce or come up with this one, instead of coming up with C as the midpoint definition of midpoint, we could be saying that, looking at that diagram, that the length of AC is going to be equal to the length of CB, and this is called definition of congruent segments. So because they're not being very specific and we don't know the order of the entire proof, I could totally understand why on this worksheet you would come up with this conclusion as well. All right, in the second one, we are given that C is the midpoint. So what are we going to be able to conclude? Well, anytime C is the midpoint, the first thing they want us to know is that AC is going to be congruent to CB, and that is definition of midpoint. All right, going on to the next one here. So number two, again, if you haven't tried it, please make sure you give it a try before you do this. All right, they're telling us that AC, so this, what happened there? AC is bisecting diagonal BD. So AC is bisecting BD. So we can conclude that DE is going to be congruent to EB. And this is going to be definition of segment bisector. All right, in the next one, perpendicular lines. Perpendicular lines always mean that you have right angles. So anytime you have perpendicular lines, it means you have right angles. If you have right angles, then we can say they are congruent. So this is saying we have some perpendicular lines. So that means that we can now say that angle ADC and angle CDB are right angles. Okay, and this is definition of perpendicular lines. All right, in this next one here, last one on this page, I think. We're given that BD is bisecting this angle. So BD is coming in and bisecting this angle. Conclusion is that angle ABD is going to be congruent to angle DBC, and this is going to be definition of angle bisector. So sometimes it's definition of segment bisector, sometimes it's definition of angle bisector. All right, number 5, if we have two intersecting segments. So when we have intersecting segments, there's a couple different things that we could say here. When we have this is intersecting, so this is making a straight line. So we could say that angle 1 and angle 3 are supplementary. Long word. And why can we say that? That's a definition of a linear pair. Now, we can not only say that for 1 and 3, you can also say that for angle 1 and angle 4 and the rest of it. You could also say it for angle 4 and angle 2 and the rest of it. And you could also say that for angle 2 and angle 3 and all the rest of it. Okay, another thing is when you have two intersecting lines and we talk about two non-consecutive angles, we could say that angle 3 is congruent to angle 4. And what reason would that be? It's because we have vertical angles. So not only can you say that with 3 and 4, but you could also say that with angle 1 and angle 2. So from this diagram, depending on what they're asking you to do, any one of those conclusions is going to work. All right, looking at number 6 here. Given angle 1 is complementary to angle 2. So if 1 is complementary to 2, then we know that the measure of angle 1 plus the measure of angle 2 is equal to 90 degrees. Okay, reason? That is the definition of complementary angles. Complementary angles. That's a long word too. All right. This keeps jumping on me. I don't know why. All right, BD is bisecting AC. So BD is coming down and bisecting AC. So we can say that AD is going to be congruent to DC. Why can we say that? That's a definition of a segment bisector. Oh, I forgot the C. Bisector. All right, given that in number 8 now, moving on, E is the midpoint of AB. E is the midpoint of AB. So you can see I just automatically, as I was reading that, and I went into my diagram and I marked it, so we can say that AE is congruent to EB. And why can we say that? That is the definition of a midpoint. So definition of midpoint and segment bisectors, you might get the same result, but you just have to have different reasons based on what they are given you. Okay, hope this worksheet helped a little bit with some of those conclusions and the reason why we can make those conclusions.